Right, you guys, let's check out those examples. All right, now that we know the precise definition, we'll look at these. So here's one similar to the one we've been working with. We've got the equation of a line, we've got x approaching -1. We see what it's equal to. We'll find the value of delta that corresponds with epsilon equal to 0.02. So we have an actual value of epsilon there that we can use. And then in part B, we'll find the value of delta for any epsilon. In the second example, we're going to look at a quadratic. We'll find the value of delta that corresponds with this value of epsilon. Okay. I'm going to jump over to my paper here. Let's do this. The limit, that first one as x approaches -1, 10x plus 1. We can say, well, we were told what it equaled, but even if we just plug it in, we can confirm, right? -10 plus 1, that would equal -9. So in part A, find delta that corresponds to epsilon equals 0.02. Okay. So here's where we begin. This part. The absolute value of f of x minus L less than epsilon. And in this case, we're just going to plug in our parts. So there's f of x, 10x plus 1. L is the answer to the limit, -9. That's less than our epsilon, 0.02. Okay. The idea is we're going to clean up what's happening here with our absolute value. We're going to end up factoring something out, dividing, and it's going to, what is going to appear with the absolute value is going to tell us exactly how close x is going to have to be to -1. Okay, so let's check it out. Let's see. So this is really adding 9, right? So we've got 10x. Oh, 10x plus 10 less than 0.02. We're going to factor out 10. X plus 1. We're going to divide by 10. 0.002 in this case. And if you notice that x plus 1 is the same as x minus -1, it'll make it a little bit more clear. So the distance between x and -1 is less than 0.02. So that's our answer for delta. Delta equals 0.02. Pretty cool. And we kind of see that theme, right? The slope was 10. So we know that, if we make 1/10 of epsilon, just the way the nature of that here would be really steep. Oh, actually, we're at -1, right? And so let's see, goes through a +1. Yeah, this is, this real steep thing. And wherever it hits, that's at -9. So we made this little cloud and try and line this up a little bit better. So because of the steepness, we end up with a much smaller cloud. It should be 1/10 the size, around -1. Okay, pretty cool. Part B, find delta for any epsilon. Well, we could probably guess the answer already, right? Knowing it's 1/10. But I'll show it to you from the beginning. So we'd say absolute value 10x plus 1 minus -9. This time is less than epsilon. From here, it's going to feel very similar. 10x plus 10. Factor out the 10. Divide. And there we go. Epsilon over 10. Got it. Got it. Okay, very nice. When you are working with something that is a line, you know, they're all going to really feel very similar. Details change, obviously, but there you have it. A quadratic. Now that's another story. The limit as x approaches 4. X squared minus 3x plus 1 equals 5. And the question was, find delta that corresponds to epsilon equals 0.5. I might think, wow, 0.5, that's kind of big for an epsilon. Well, maybe, right? Like, again, like what is big and what is small and what is approaching. And, you know, maybe for some functions, 0.5 is actually, you know, on the small side relative. Let's see, round to 3 decimal places. I'll take that here too. It's all relative. All right. Here's what's different about this one versus linear functions. When you have a quadratic, this quadratic is curving. And so it's not going to end up being the same distance on the left and the right sides of 4. It's still going to be 0.5 on the y values either direction. But because it's sweeping through, right, if I just kind of draw it really fast, right, x squared, it's kind of like curving up, you know, then this is not at all what it looks like, obviously, but right. So if you're here, here's L, and you're the same distance there and there, it's not going to produce, here's A, it's not going to produce the same distance around A. Because it's curving steeper and steeper. Actually, I didn't do a very good job of highlighting that. It's going to come in and then drop. One side will be closer to A than the other. And actually, it should be, I believe it's this upper side will actually end up being the closer one. I'm not like really dropping this straight down. Okay, that's better. You know, if it's curving like this, then the lower side is going to end up being a little bit further away. Because it's steeper here, this is going to be a little bit tighter into where A is. So we're going to have to find a way to kind of deal with that. Which means we don't, for like the procedure of doing this, we don't want to use absolute values. Although, you know, we could set it up that way initially, we're not going to keep the absolute value throughout the problem. So we could still say like absolute value x squared minus 3x plus 1 minus 5, right, is less than 0.5. what we're going to do immediately is say, okay, what does this really mean? It means our function is somewhere between 4.5 and 5.5. So where it's like we're going back to that original method, that first way we did at the beginning of this section. Hey, I'm coming in towards 5. I know it could be 0.5 either way. So that means my function is somewhere between 4.5 and 5.5. And I think that's a lot easier to wrap our head around where to go from here with a nonlinear function. Because here's what we're going to do. We're not going to isolate x, right? The way we did it with the linear. It's just the math's just not going to work that way. We're going to say, okay, let's think about this. So this tells us where those boundaries are. The lower boundary, talking about the lower boundary down here around a, that would be when my function is equal to 4.5. All right. Where my function equals 4.5, what x value would that be? That's my lower boundary. My upper boundary of x is where my function equals 5.5. So what I'm going to do is just solve each of these separately. And then we'll have it. We don't need to do it in this kind of slick style with the absolute value. There's no slick style here. We kind of got to do it the long way. But, you know, maybe the long way is something we're more familiar with. How are we going to do that? Okay, let's look at the lower one. We're going to say, all right, if we subtract the 4.5, set it equal to 0. Okay. Why do we set it equal to 0? Because at this point, it's not going to factor. We got to use quadratic formula. X equals, you guys remember it, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Oh yes, x equals negative b, well b is negative 3, so there's negative b, plus or minus square root b squared minus 4, here a is 1, c is negative 3.5. That all gets divided by 2 times a. Yes. All right. So what do we have here? That's 3 plus or minus. If you do all of this work, let's see, that's going to be 9 plus 14, I think. We're going to end up with 23. It's over 2. It's going to give us 2 results. Let's see here. Try my calculator. 3 plus the square root of 23. Divide that by 2. Here's what I'm getting in my calculator. It's not giving me the decimal. So if you've got a calculator like mine, the 36X, you can hit this little double arrow on this button, and that will convert it to a decimal. Pretty nifty. Okay, we got to round to 3 decimal places. 3.898 when you round it. That was when we added. If we subtract 3 minus square root 23, divide that by 2. And we also have negative 0.898. Okay, at this point, we've got 2 possibilities for that lower boundary. We're not sure which one it is. It's only one or the other. Let's think about it though. Here, right, that lower boundary, x is approaching 4. So which one does it appear to be? 3.898 or negative 0.898? I think it's probably this one, since x is approaching 4. All right. Let's do the same thing for this upper boundary. X squared minus 3x minus 4.5 equals 0. So x equals negative 3 plus or minus square root negative 3 squared minus 4 times 1 times negative 4.5. That's all over 2 times 1. So that's 3 plus or minus. What do we got here? 27. Okay. Over 2. All right. Let's see what we got. We got 4.098. All right. And when I subtract negative 1.098. Okay, well, yeah, it's not this one. It's the one close to 4. Now let's think about this for a moment. It turns out, as we discussed at the beginning, these numbers are not the same distance away from 4. If I was to draw just a quick like x-axis, right? Here's 4. $3.898 is down there, let's say. 4.098 is up here. Now they're pretty close, but there is a little difference. How far are these distances? This one, that's a little bit easier. Well, that's just 0.098, right? I think I need to sharpen my pencil a little bit. But what about this distance along the bottom? How far is that? Well, if you subtract them, that distance is 0.102. Okay. When we get an answer for delta, find delta. There's only one number that it can be. And delta is the distance away, right? The distance from 4. So should we take delta to equal the bigger number of the 2? Or should we take delta to equal the smaller number of the 2? Let me just tell you guys. Take delta as the smaller distance. Why is that? Because that one works in both directions. What do I mean? If you take delta to be 0.098, then you can go all the way up to 4.098, and you will still get your function x squared minus 3x plus 1 to be right at 5.5, no problem. You did not go beyond 5.5. And on the lower side, you can go all the way down until you're not going to get the entire portion there, but you're going to come up just a little bit shy. And that's okay to only go 0.098 in this direction, because that's still going to land you greater than 4.5, right? You did not pass below it. So everything is safe if you take the smaller number. What if you were to take the bigger number? Well, it would be fine down this direction, right? You would hit that lower edge, and that would give you, that would make it equal to this. But in the opposite direction, you're going to go a little bit too far and you're going to go beyond 5.5, or you're going to allow X values that give you a function value bigger than 5.5, that's not okay. That's not less than what's allowed. So we're forced to choose. Delta is, as you can see from my drawing, it's got to be symmetrical. And so because of that, we have to take the smaller value. So here, delta to 3 decimal places, 0.098. All right, you guys, hope you enjoyed that. That is it for the precise definition of a limit.